Okay, voice is on. Hello, good afternoon, everyone. I'm Manoj Reja. I'm Principal Program Manager with Azure Data Explorer team. This service was just launched on Monday. We announced it at Scott Guthrie's keynote. Anyone attended Scott Guthrie's keynote on Monday? You were there. Anyone attended Rohan's keynote? No? Okay. So a lot of content will be new for you. Um, So we're going to cover, overview of Azure Data Explorer and how to run queries in seconds on billions of records. So what's Azure Data Explorer? It's a fast and highly scalable data exploration service. It's optimized for low latency ingestion as well as lightning fast query performance. We can run queries on billions of records in just few seconds. And we also support three types of data. We support structured data, unstructured data such as logs. We support semi-structured data such as JSON. And this particular project started as an incubation project within Microsoft, and to solve some of the telemetry needs for cloud services like Azure, Office, and Windows, where we couldn't find a solution that can scale to the needs that we had. We ingest petabytes of data every day and run about 11.5 billion queries a month on all the clusters to kind of run analytics. So it became pretty popular and widely grown into all, or was adopted by all the Microsoft services. So Microsoft Windows, Office, Xbox, everyone uses this some or the other way. Azure Data Explorer is also backend for some of the third-party services like log analytics, application insights, time series insights, and so on. We are bringing you the same service that we are using internally, and we want you to take advantage of it to build rich analytical systems on top of it. Here are some customers. They've already utilizing. Here are some customers. They're already taking advantage of this service. So let's get into a demo, and hopefully we'll have some time for Q&A at the end. If not, then we are right. Our booth is right here, so we can meet on that booth. So to get to a service, first you would provision a cluster by logging into Azure portal. We'll give few minutes while it logs in. So once you create a cluster, there are different choices, different SKUs that you can choose from. We have 8 core machines and 16 core machines. There are machines for compute optimized workload, storage optimized workload. So it's pretty simple here. You create a cluster. You create a cluster on this platform, and once the cluster is created, it's going to show like this. Yeah. So once you create a cluster, you can choose from like 2 nodes to n number of nodes, and you can auto scale or you can manually scale it. So I already created a cluster. You can go to the scale out capability here and then configure, just slide on how many nodes you want to add in. As your workload grows, you can just move the slider and add more nodes to the cluster. As well as you can enable auto scaling and then configure parameters on how you want it to auto scale or auto shrink. So once you have your cluster ready, you would go and create databases. So I already have a demo database created here. So GitHub is my database already created here. So you create database, you create objects like tables and functions that you want to query on and so on. And also adding a ingestion pipeline is pretty easy. We have deep integration with Blob, Event Hub, IoT Hub. So in this case, you could just go to the ingestion and then add a data connection and fill in your Event Hub details. That's it. That's what we need. And then we'll start streaming data into the platform. So once the data is in, you can use any of our tools and APIs to query the data. So assuming we have done all this work and the data is in, so here is one example of a data set that we ingested from GitHub. So anytime you interact with GitHub, it creates one activity. And there are different type of activities, push events, pull events, and so on. So we have uploaded about 1 year of data. It's about 1 billion records. So let's look at how many records we have here. So the tool I'm using here is called it's our web UI that you can that you use to connect to the clusters and query from your database. So let's look at this data source. So it's about 1 billion records for last 1 year. See how fast we ran, and within few seconds we were able to go and get those counts in. Let's look at the size. So this is about 2.8 terabytes of data stored in our platform. Let's look at schema. So GitHub data is a little bit complex schema. It has structured data like ID, type, string, public, boolean, and date time. But it also has JSON data, which has payload information, repo information. This is all part of the JSON. So we all, as I mentioned, we support semi-structured, structured. So there's a good example of structured and semi-structured in one table, where you can have dynamic columns where you can store dynamic values. So let's look at some sample data from those tables. Here if you see, we have type, push events, watch event, issue events. There's just a sample event, and we pulled some sample rows from those events. You can see there's a complex structure here. You have a JSON, and then there's an array within JSON, and so we can store that JSON in a native format, and you can query at runtime. So here is one example where we came up with the popularity index, did some came up with some formula that we want to figure out what are the top 5 repos on GitHub. So what this query is doing, so there are two parts to it. We are running one query to understand the watch events, and then the other one is getting query to understand the issue comments. And you would notice here repo.name. This basically a repo is a column name which has JSON data, and then we are extracting that value from the name element, and then bringing the data together, joining it here, applying some calculation, our custom calculation. This is something that we came randomly, and then we created a computed column, the exactly same how you do it in Excel. So you create a computed column and then run aggregations on top of it. Let's run this query. It ran within like few seconds and queried about, scanned through 1 billion of records, and applied all the JSON extractions and then all the computations, and within few seconds we have our aggregated results available. So you can see the top 5 repos. It's good that we have Microsoft Visual Studio, one of the top 5 listed here. We can go and drill in more, compare the data. Let's look at the next query. Oh, by the way, another thing we can do here is, now many people are visual, like people like visuals. If you give a table, it doesn't make much sense. I want to visualize it. Many times in old days, you would copy this into Excel sheet or some other tool and try to visualize it, just to make sense of the data. We support some of the rendering capabilities out of the box from the tool. So you just add another additional command, render. Pie chart, and it just gives you, it runs the query, gets the data in, and renders right here. So you don't have to jump between different tools. Another cool thing you can do is, let's say you identified these insights and you want to share it with your colleague, you want to collaborate with others. Other thing would be, you would go to the table and try to copy it into Excel and something, send an Excel to somebody, and they say, hey, look at this data, cool data. And then that guy will come back and say, hey, by the way, can you try, instead of top 5, can you do top 10? And then you do back and forth. So we made that sharing easy. all that you have to do is go to the sharing, and then you say click link to results and clipboard. Go to your Outlook or any other tools that you are using, and you can paste right there. That sends your query as well as a deep link to that query. So the receiving party, if he has access to the source or to the database, they just need to click on the link, and then it straight goes to the tool, logs in, single sign-on experience. It'll connect to the right cluster, right database, run the query, get the exact same results. Now you can go and just change it and rerun that query. So we just did a simple rerunning. We also have we have documentation around how you can construct your own deep links to integrate into your applications. So we looked at some of the complexities here with GitHub data, where we had 1 billion records, and we are trying to query JSON data, structured data. Now let's switch gears. Like the other data set I want to show is about 40 billion records. We are moving from, again, this is not the highest data set that we have. We have data sets which ingest more than this. This is about 30 terabytes of data set that I'm going to just show you. So this particular data set is in a sample data set from Power BI telemetry, and let's look at what we have here. So these are about 5 tables. There's 30 terabytes of data spread in 5 tables. So anything that you ingest in Azure Data Explorer is indexed by default, compressed by default. And you can see you have different compression ratio here. You have 30, this table is 30x compressed. This one is 11x compressed, 17x compressed. Depending on your data, you get a different compression ratio. So it's about a 30 terabytes compressed and stored into the system. So this particular cluster is running on 7 nodes. You can see different nodes, and you can configure that through the scaling that I showed you in Azure portal. You can shrink it, increase it as your workload. One of the customer came to our booth. He was asking like, hey, every month, or end of the month, or end of the year, I may do some additional processing. I need more horsepower. So just increase the power capacity, do your job, bring it back down. So let's look at one of the table. So this is one of the table that we are exploring. This is about 41 billion records. You can see how fast it ran, count, and got the results. It's about within a second. It ran about 352 milliseconds. Let's look at the sample data here. So here we are running aggregations. Now the use case here is I am a DRI, or I want to figure out what's going on with my application. So you start with a higher level view. It's like what are my top error levels I'm seeing. So in this case I just did a group by. This is basically summarize count. Is group kind of in group by level. Level is one of the column in the table. And I ran this summarization on around 800 million records, and it's just written within a second. Let's look at the sample data. So if you see this particular table has a lot of structured data here. You have GUID, some of the string, datetime columns, and one of the column at the end is unstructured. So this is all unstructured data, some kind of logs that we want to do analytics on. Now, I have this data, and I want to understand, okay, I get this, there are different type of errors I'm seeing. Now I want to know who are my top frustrated users in the system. So for that, I want to know what the user IDs are, but I don't have user ID in my structured data, but it's available in my unstructured data somewhere sitting here. So we're going to run a different query for that. So here, what we are doing is declaring some variables where we set the date time that we are interested in. Then declare the query that we are interested in. Put a timestamp on where we are going to query, and this is the most interesting one. So we are going through millions of records, identifying where the event has certain text, and then going and extracting the user ID. So this is a regex. You can do whatever you want. It's just an example here, but you can write your complex regex statements here and create a computed column, and then do aggregations, joins on that particular column. So that's what we are doing here. We're extracting that user ID, doing a join, and within 2.5 seconds I have my data available. Again, scan through millions of records and got this data, and I know who are my top two frustrated users here. Let's switch gears and look at some other type of data. So this is kind of a time series data. This has about 30k time series, about 35 billion rows. Let's do count. So you have different metrics here, different kind of performance counters. In IoT use cases, you might have different metrics coming out of IoT sensors and some of the values associated with it. So it's a time series data. Now in this case, I want to figure out, what are different roles or computers or machines that are having higher CPU spike or showing an abnormal CPU growth. So I would run this. So here, again, it's a simple statement. We are going after a specific date, declaring the query that we are interested in with the timestamp, and then filtering the data for a specific counter, and using some of the advanced capabilities in Azure Data Explorer. So in time series scenarios, you may get a continuous data, or you may get data in gaps, or let's say you are getting data every 5 minutes, but there may be a situation where you didn't get any data. If you just do a normal graph, you won't notice that. But there we have capabilities where you can bucketize those data in a windows, and then make a time series set. So that's what we are doing here by time, and by a 15-minute rolling window. And then running some advanced capabilities to go and query that data. Let's run that. So it will run for a couple of seconds. So it ran about 6 seconds, and then here it went through those records, and then figure out what are the different CPUs which are showing those abnormal patterns, and then plot those CPUs. So now I can go deep dive into those particular machines, look at the logs, and find out what's going on there. So we looked at two demos. One was complexity side on a structure. The structure is complex. The other one is more on how do you do analytics on top of unstructured data, and then bring that together, run those faster queries. Okay, so we may say, hey, this is cool. How do I use this system? How do I bring my data in? How do I query the data? So you have multiple options. It's easy to get data into Azure Data Explorer and easy to query it. We have many options. So we have .NET SDK, Java SDK, Python SDK to help you, ingest data. We have deep integration with Blob, Event Hub, IoT Hub, Event Grid. So if your data is in Blob, you just need to queue up a message with the cluster, and cluster is responsible for pulling in the data from Blob, doing the retry logic, handling the transient failures. All those things are handled by the system. You can also take advantage of Event Grid, where you can configure as soon as the data lands into event Blob, Azure Data Explorer will be notified, and then we'll ingest that into the system. Also, if you're interested in streaming scenarios, you can stream data to Event Hub or IoT Hub, and then we stream straight into Azure Data Explorer. It's in deep integration, so you just have to go to Azure portal and then configure those pointers to the Event Hub. Just covered, we support bulk and streaming ingest both. So once you get your data in, extracting data is easy. You use one of the APIs, .NET, Python, Java, use JavaScript, or IDE Monaco editor. So Monaco editor is basically, the query tool that I showed you, where we were writing queries. you can just take that. Even if you are an ISV or if you want to build your own white label application, you can take that, embed that into your code, into your workflow, and then just use it. So it's a Monaco editor available for you to consume. We have Web UI. We saw a demo on Web UI. We have similar application available for desktop. Um, we have Jupyter Magic and support for Azure Notebook. So you can run, create notebooks and run queries against Azure Data Explorer. We have connectors to Power BI Direct Query. We have Direct Query connector for Power BI, Microsoft Flow, Microsoft Flow App Logic, and we'll be releasing soon connectors for Grafana and ADF that will help you to build end-to-end pipeline. And lastly, we have REST API supports and also support for MSTDS endpoint. So you saw the language, the richness of the language that you can do. We have about more than 350 operators and more advanced operators that you can use. Very simple to use. But if you have such scenarios where you are married to a certain visualization tool and we don't have a connector ready, you could use the MSTDS endpoint. So any tool that knows how to connect to SQL Server can connect to Azure Data Explorer and send SQL queries. But we do recommend using our query language for performance. So those are different options available for you, and this list will keep growing as we move forward. That's what we to start with. So how many of you feel interesting about this? Would like to try it out? So we have a help cluster available. So it doesn't cost you anything. You go to the link, it'll guide you, how to connect to the help cluster. It's the same user interface that we saw. You connect to the help cluster. It has a Storm events database, a smaller table, but it helps you to play with the query and have a feel of how this technology works. And then you can bring and create your own cluster, bring your data in, and then so on. Here are some other resources that will help you to learn more about the technology. We have also released white papers on Monday, which goes very deep into how the technology works, how we do sharding behind the scene, how we store data, how we distribute data across nodes, how do we bring in data, and what are the things makes it so fast. So if you're interested in going into some kind of research paper, then I would recommend go look for those blogs. Search for Azure Data Explorer Technology 101 and white papers. So those blogs go very deep into the technology. So that's what we have. I think we are 3 minutes over. But if you have any questions, I will be available on the booth. Stop by and we can have discussion there. Okay, thank you.